Okay, welcome members. Today we are going to handle the solutions of UACE Advanced for 2020, Paper 1. As we've seen, we have covered all the topics for Paper 1 and then Paper 2 for also O level. Now we are going to see how the papers are pairing. So this is for UNEB 2020. You know, a full paper has two sections, Section A and Section B. Section A with 8 questions, each 5. Then Section B is having 8, but we are doing 5, but with each adding 12. So I'm going to show you a sample. This was, as you can see there, this is Section A. That's how the questions are. Then Section B, question 9, then complete is there, as you can see there. Then we turn over, and then after when we reach section, the last part of Section B. So that's how the paper was. So what we're also going to do, we are going to focus on now. I'm going to do two questions, but then I pause, I write again, then I read so that we can complete the rest. So we are going to handle that basic. So I'm going to start with these ones. This was 1 and this was 2. Each was carrying 5 marks. So it will say solve the equation this for this. Now this is the name they are giving you. But please don't forget to subscribe to the channel. Everything is the topics of all this is trig, this is complex numbers, all those topics are there already. So we covered them in detail. So they are there in the playlists. You can list them and then you see the detailed work. So we handle 1. So 1 is the number of trig. It's falling under trigonometry. So it's here. So what we had to do here, the idea was first use factor formula. But use factor formula, you see this angle is 1 and this is 2. When you add and divide by 2, you don't produce this. Even if when you add this and divide by 2, you don't produce this. So therefore, we had to rearrange first. So rearrange this, and you end with this one. Because it's when you add 1 plus 3 divided by 2, you get 2. So these 2 are reproducing this. So that's why you had to first rearrange, as we are going to see. So now, this will be now sin x sin 2x equaling 0. Now here is factor formula of sine. This is going to be 2 now. Sine, we add this plus this, that will be 4 divided by 2, which will be 2x. Then we get this minus this, which will be negative 2x divided by 2, which will be negative x. But remember, cos of an angle the same as cos of a positive angle. Cos of a negative angle the same as cos of a positive angle. And so that's why this one is going to be like that. Then plus sine 2x equaling to 0. So now here, I think we have replaced this angle. So the idea here is factorize out this common angle. So there we are in sine 2x. I remove it. Here I made sine, and then 2 cos x, then plus, here I made it 1 equaling to 0. So either this is 0 or this is 0 because it's the product of two functions. So either sine 2x is 0 or 2 cos x plus 1 is equaling to 0. So now we see, now this angle is twice this. So meaning, we first correct this. So meaning, if I multiply this by 2 for this one, I'm going to be having here 0, so that by 2x, so that I can, this function correspond with this. Then I have 180 times 2, which will be 36. So my 2x here will be sine inverse of 0 is 0, comma. Another one is going to be 180. Then another one is going to be 360. Because I multiply this by 2, that this angle is the same. That's why for 2x, I'm including in 360. Sine of all these angles is going to be 0. So then after dividing by 2, our x becomes 0, 90, 180. Now, when I handle this one here, right, you see now when I take this side, I have cos x equaling to negative r half. Now separate it's x and this one is x, so meaning this one is going to, we are going to use this way because this is x and this is x. But when you see this is negative, it's negative, implying it's going to be in the cos is negative in the second and the third quadrant. But because I'm not going to include the third quadrant because it's out of the range. You see, this one is stopping only in the second quadrant. So here I'm just going to include second quadrant. Because of the range for 0 less x less 180 degrees, that's why I'm including only this. So here our x is going to be, how do you get the angle? The diagonal of this, cos inverse of 0.5 is going to be 60, but that's an acute. But we are in the second quadrant, so you get 180, then minus the acute. Cos inverse of a half is 60. So our x here becomes 120 degrees. So there, the x, I think we can look at the range here. So our x will be now 0, 90, 120, 180 degrees. So that's what you had to do. And I think all these angles are falling in that range. When you come to number 2, so for number 2, they are giving us a complex number there, as you can see. They are telling us that express this in the form of a plus bi, where a and b are integers. So my z can every c is equal to. So what do we have to do to rationalize this? Rationalize is you multiply this, the conjugate of this up and down. So the conjugate of this is going to be now the conjugate of this up and down. So here our z is going to be this times this. Remember, here you have the top 3, then this times this plus 3i, then plus I, then minus cos I squared. Remember, our I squared is negative 1 I squared. So multiply this and this, that's why I have negative 1 over this and this. There is a difference of 2 squares. We have 1 squared minus I squared. So up we have 2. So here is that our z up. So we minus this, we get 2. Then this, we get 4i. Now over this is going to be 1. When you square I, we get a negative 1, a negative and that. So we have 2 there. So my z there becomes this 1, then plus 2i. And so that is z in form of a plus b. I think that's how you can see. This is my z. Then part b, they are telling me to get the argument. I think we know how we get the argument of number. So see that this one is in the first quadrant, this one. So the argument of z is going to be, say, tan inverse of the imaginary over the real. So 2 over 1. So our r of z is going to be, I'm doing this because this one sits positive and positive. So you see, this one is going to be in the first quadrant here, the r of z. So here, the r of z, you see, it's falling here. Our z is in this, where we have 2 and then 1, and then 2. So our z is falling in this. Because all of them are positive, and this is how we get argument in the first order there. So tan inverse of that. So here I'm getting 63.43. So that is the argument of that. Or if you want, you can convert radians, or you can say the arc of z is going to be 63.43 over 180. Then introduce radians. All of them are okay. So that's that's why I had to handle number 1 and number 2. I'm going to pause, I write number 3 and 4, then we replay and we see how I can go about it. Here now we have our number 3 and then number 4. Given that y is equal to this, find y dx, then here they are giving us a vector. So this is a number that is falling under differentiation. So this one is falling under vectors. So to differentiate this, we have first of all use properties of logarithm and indices. So if I'm to expand this is going to be y equal to natural log of x into x plus 1 power 3. Remember this square root, the same as a half. So I'm going to put it as a half, but if you now is functions less than 2 powers, more than 2 powers, those 2 powers multiply. So this is the same as that. So it's now here, I'm going to apply properties of logarithms. So y will be natural log of x, then plus natural log of x plus 1 or 3 over 2, which you can able to see this power is going to come here. Then this will be natural log of x plus 3 over 2, natural log of x plus 1. So from this step, you have come to this step direct. It is very okay, you will get all your marks. Then from here, we differentiate. So the y, the x, differentiate natural logarithm, you differentiate this function, divided by any function. 1 over x, then plus 3 over 2 into, when you differentiate this, you will get 1 over this function x plus 1. So that's how you differentiate natural logarithm. Then what is left is just to simplify. So the y, the x, you cross multiply this here, so you have 2x plus 1, then plus this times this, 3x, all over 2x into x plus 1. So simplifying that, our y x is going to be, so this is going to be 2 plus 5x all over x. Anyway, you can start with the 2x whole, but to maintain, so this one is just going to be 2x into x plus 1. So that's what we had to do. As simple as that. Then we come to number 4. So this is our number 4. So number 4, they are giving us equation. So they want us to put the equation of the plane. So this equation of the plane is the plane we are having. So this plane has a point P. It has a point P. This point P is negative 2, 0, 4. So this is the point in P. And then telling us that it's perpendicular to a vector. So it's perpendicular to this vector. This vector is R. This is R equaling to I, which I can write in column form as a column vector. I can now write it as 1, 3, negative 2. So in simple terms, this vector here was acting as a normal. So in order to get the equation of a plane, we need the normal to that plane, then we need the point in that plane, so that we can use our formula of n r equaling to na. So now this one is going to act as our normal vector, which was given as in this case. So from there, our normal vector is 1, 3, negative 2 into x, y, z. This r is always a general point on the line form. You can write it as capital R, so that you can differentiate it from this one there. So this step is our P in simple terms. So from there, okay, so this A is our P. Okay, it's the same as N R equaling to N dot P, because our P is now a point. So this R is a general point. Our normal is 1, 3, negative 2. Then times a point. This A is a point on the plane, which is that 0, 4. This will give us x. We are dotting these ones. We are dotting. This is the dot product formula. So this times this times this, minus 2z equaling 2. That is okay. Negative 2 plus 0. Then this times this plus a negative 8. And so our x plus 3 pi minus 2z. This is negative 10. And bringing this side, half plus 10 equaling to 0. And that will be the equation of a plane with ease. So that's how we had to do number forming ease. This is very simple product formula, as simple as that. See, I'm going to handle now 5 and 6. Okay, this was number 5 and then number 6, as you see. So number 5 was just integration. So this is falling under integration. This is falling under combination and permutation. So in this section, they pulled out this. Now, to handle this one, here we are going to use, whenever I say you have the square root tan. So you know that from now, use our second Pythagoras identity in 3, which says 1 plus, now basing on the angle. So this angle is x over 2. It means this is going to be x squared x also over 2. So this was the angle was half, even this was half. So now you make this the subject, because you know when you differentiate tan, you get x squared. Meaning when you double x squared, you will get tan back. So we substitute this, we make this the subject from here. So now my I from here is supposed to be now integral from 0 to pi over 3 into now. I make this the subject, I take this the side. So I'm going to be adding x squared x over 2, then minus 1 dx, making that the subject there. Then here, next step is to separate. This would be now integral from 0 pi over 3 into sec squared x over 2 dx, then minus integral from 0 pi over 3, then here you have 1 dx. And then there, the task is now to integrate. So this will be, you don't have to integrate sec squared. First of all, you first differentiate the angle, then you divide by that angle. So, divide by this angle, you get, when you differentiate this angle, you get a half. The reciprocal over half is 2. So you have now 2, then when you differentiate sec squared, you get tan of that angle from 0 pi over 3, then minus, when you integrate this, you get x from 0 to pi over 3. So now we just substitute here, put in the upper limit first. So we have now 2 into, I have now tan pi over 3 over 2, then minus, okay, let me do this here like this, then minus, when I put in tan of 0 over 2, then minus this one, remember this one we have pi over 3, then minus 0. So here, your catheter should be in radians. Anyway, we know that pi is 180 divided by 6. This will be 30. So this will give us 2. You know that tan of 30 is the same as tan of 30 is the same as root 3 over 3. Also, I'm write it 1 over root 3. Okay, 1 over root 3. And tan of 0 is going to be 0. And minus, this we shall be added, pi over 3. Then press. So now our integral from 0 pi over 3 of tan squared x over 2 dx is going to be, make sure that your angle is in radians. Then you give it for the small places. So the first thing to do is to put the catheter in radians. Then you press these things here. So the answer I'm getting 0, 7, 5. You indicate if you are giving this to 4, the small s's, and that will be the answer. So that's what you had to do there. When you come to number 6, this one's number 5. When you come to number 6, now in number 6, we have the word Bundesliga. Bundesliga. I think you know the Bundesliga is a league for German football. So then, they want us to get the words can be arranged if there is no restriction. If there is no restriction, you just count the letters. Then these are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10 letters. So these ones, so part F, this can be arranged in 10 factorial ways. And now when you look at them, there's nothing repeating. If there's something repeating, then we divide by those. And now you see here, everything is different. So number of ways here, we are going to be having 10 factorial. Nothing is similar to each other, as simple as that. So there are 10 letters. You see, all of them are very different from each other. And then you get this and you press it on the calculator. So 10 factorial is going to be, so here we're getting 3, 6, 2, 8, 8, 0, 0. So those are the number of ways you can arrange this word without restriction, as simple as that. Then part B, when vowels are together, vowels together. So now, if I put all vowels together, I'm going to be having now boo, I come with E, then I come with I, then I come with A. So these are the vowels we have. Then I have N, B, S, L, G. So those are the ones I have. Now, if the vowels are together, you treat this as one letter here. But these vowels you can arrange. You can start with the E. You can arrange these vowels. First of all, they are 4. So you have 4 vowels and you have 4 consonants. So you can arrange these vowels together. They are together, but you can put this here or this here. So you can arrange these ones. These ones can be together in 4 factorial ways. Now, if you treat this as one word, so this is going to be 1. Now this one is going to be 1 letter. So when they are together, you treat it as 1 letter. So this is 1, 2, 3, 4, 5, 6, 7. So there are 7 ways. But in the 7 ways, these ones themselves can be arranged in 4 factorial ways because they are 4. So here, number of ways. We are going to be having number of ways. We are going to be having 7 factorial times 4 factorial. These 4 factorial, these ones, the vowels themselves, U, E, I, A. These ones can be arranged in 4 factorial ways. So that's how we had to do this one, and then we just press the calculator. 7 factorial times 4 factorial, and then the answer 960. So that's how we had to do that now with the ease. So never we put them together, but don't forget always, if you have 4, you can always arrange them in 4 factorial ways. We covered this topic, it's there already, you can go and visit it. Also, we covered this integration, you can go in the playlists and visit them. Okay, we are remaining with now number 7 and 8. So here we have our number 7. This number 7 was coming in a section called the conics, or the conic section, where we have ellipse, parabolas, and hyperbolas. Hyperbolas, you know, there are some what we call the rectangular hyperbolas, but specifically this was from ellipse. And then all those topics are there in the playlist. You can visit them and see Then this one is coming from differentiation, where we have how we did the gradient of a curve. So to get this, this is an ellipse. You know that our ellipses are always in the form of x squared over s squared plus y squared over b squared equal to 1, where the vertex is at 0, 0. So what we have to do for ellipse, for an ellipse, then we know that this is has to be like this over b squared equal to 1. So from here, you can start now. My x over 9 is equal to cos theta, comma, and then y over 12 is equal to sine theta. But you know that there is an equation that relates these two. This is from cos squared theta by sine squared theta equal to 1. Then here we shall be having x over 9 squared plus y over 12 squared equal to 1. So this is going to be x squared over 9 squared plus y squared over 12 squared equal to 1. Hence, an ellipse. Why do I say it's an ellipse? Because it's in the form of that. Then this is part A. Then part B, the one has to get the eccentricity. That's that A is less than B. So from there, what we use is so that a squared is b squared equal to 1 minus b squared, where A is the eccentricity. So now, when you compare these two, I think it's that our a squared is 9 squared. So this is 9 squared equal to 12 squared into 1 minus b squared. So from there, you can easily see this is going to be 81 over 144 equal to 1 minus b squared. Which when I come here, I take this and take this aside, my eccentricity squared becomes 1 minus 81 over 144. And so from here, my eccentricity, when you subtract this from this, you get a 144 minus 81. It's going to be, when you cross multiply here, so this is going to be 63 now over 144 squared. So meaning my eccentricity is going to be root of 63 over 12. Remember, the eccentricity can be a positive or a minus, like that. Simple. And so that's how we get our eccentricity with ease. Now, from there, now we come to our number 8. Number 8, where we have find the equation of find the gradient of x squared times x minus xy minus 2y squared equal to negative 2. So we know that to get the equation of the curve, we differentiate that curve and then we substitute the points where the coordinates of x and y, where that curve passes. So to differentiate, you know that this is the product and this is the product of two functions. So there we are going to employ the idea of product rule. We covered that. So here we said fix this, differentiate this. So when I fix this, I'm going to be having now x squared. When I differentiate tan, I get x squared x. Now plus, now fix tan x. Then differentiate this, you get 2x. I'm done with that. Then I have this into, it's also a product. So it's a fixed x, differentiate y. When I differentiate this y, I get 1. But because I'm differentiating the function of y, this one now becomes dy dx. Then plus, fix y, differentiate x. Then minus, when you differentiate this, you get 4y. And remember, we are differentiating y, dy dx. When we differentiate a constant, we get a 0, as simple as that. So our task here is to just rearrange. You see that now? I have this, I have y here I have also y. So what I'm going to do there, so this is going to be x squared, sec squared x, then plus 2x tan x. Now, you see when I combine this and this, I want factor, okay, this is going to be minus y, then I want to combine this and this, so minus x dy dx, then minus 4y dy dx, all of this is equal to 0. Now, what I'm going to do, I'm going to take these ones the other side. Here I'll remain with x squared, sec squared x equaling to, when I take this one this side, remember, I'm able going to factorize out this one. I factorize out the y, the x, and I take them the other side. I have x, then plus 4y dy dx. To make the y dx to something there, so my y dx is going to be x squared sec squared x the whole over x plus 4y. Finally, it's the other side. Now, at a point this, so come and say now, at 0, 1, you see from here, your x is 0 and your y is 1. So, our dy, the x, when x is 0 and y is 1, is going to be put in 0. So you have 0 squared, sec squared 0, and plus 2 into 0, tan of 0 minus y, which is 1, now all over. Here we have our x as 0 plus 4 into 1 as our y. From here, our dy dx is going to be, this is 0, this is 0, we have negative 1, now over a 4 there. So that's the gradient of the tangent, that curve at this point 0, 1. So therefore, the gradient at is negative 1 over 4. That's the gradient of the curve, and this will also be the gradient of the tangent. So that's how we had to handle our section A. Briefly, remember you have 3 hours. So